Hello everyone. I am from Kuchbihar Government Engineering College. My name is Shruti Basu Roy Chaudhary. I am studying at Electronics and Communication Engineering Department. Today my topic is pulse code modulation in digital communication and stochastic. The basics of pulse code modulation. In pulse code modulation, it is used to convert analog signal into digital signal. In PCM, first we do sampling to convert analog signal into discrete signal. After that, we do quantization to convert discrete signal into digital signal. And then we do encoding of the digital signal. Here is the block diagram of pulse code modulation. First, here analog signal given to the sampling. Then sampling signal is given to the quantizing signal then given to the encoding for digital data. Here is the example of digital data we can see. If here is any high frequencies components are there at analog input, then we should use LPF. LPF means low pass filter, which is low pass filter. Where we should do it, there we should do it in input before we give signal to sampling. Before giving the analog signal to sampling, we use here a LPF, which is low pass filter for high frequency components in analog input. We should use LPF. Then quantization. Quantization is a nonlinear transformation which maps elements from a continuous set to a finite set. It also the second step required by AD conversion. First, analog signal have continuous time and continuous value. Then we give that analog signal to sample. Then we get a sampling signal. Then we give that sampling signal to quantize. Then the quantization signal is given us the digital signal which have discrete time and discrete value. Types of quantization. There are two types of quantization: uniform quantization and non-uniform quantization. The type of quantization in which the quantization levels are uniformly spaced is termed as uniform quantization. Non-uniform quantization is that the type of quantization in which the quantization levels are unequal and mostly the relation between them is logarithmic, is termed as non-uniform quantization. After that, we are going to talking about uniform quantization. There are two types of uniform quantization: mid-rise type and mid-trade type. Mid-rise type. The mid-rise type is so called because the origin lies in the middle of the rising part of the staircase like graph. The quantization levels in this type are even in number. Here is the explanation of mid-trade type. Both the mid-rise and mid-trade type of uniform quantizations are symmetric about the origin. It is very important point. We should note that. After that, quantization error. For any system during its functioning, there is always a difference in the values of its input and output. The processing of the signal system results in an error, which is the difference of those values. The difference between an input value and its quantized value is called a quantization error. A quantization is a logarithmic function that performs quantization rounding of the value. An analog to digital converter works as a quantizer. Then we know that there is a bandwidth in PCM, which is also called transmission bandwidth in PCM. Here is the explanation about the transmission bandwidth of PCM, where Q is equal to 2 to the power V, and then number of bits per sample is V. Samples per second. Number of samples per second is Fs. Number of bits per second is number of bits per samples into number of samples per second, which is V bits per sample into Fs samples per second. Then we have signaling rate in PCM, which is also R is equal to Vs. Bandwidth needed for PCM transmission will be given by half of the signaling rate. Here the transmission bandwidth of PCM, the bandwidth is less than is equal to half R, or bandwidth is less than is equal to half VFS, or bandwidth is less than is equal to half VFM. Then is a signal to quantization noise ratio, which is also known as SQNR, which is a short form of signal to quantization noise ratio. Signal to quantization noise ratio, SQNR, in PCM system, signal to quantization noise ratio is an important parameter in pulse code modulation system which determines the quality of the digitalized signal. It is defined as the ratio of the power of the input signal to the power of the quantized noise. It is expressed in decibel, which is denoted as dB, and higher the value of SQNR, the better will be the quality of the digitalized signal. As we see that higher the value of SQNR, better will be the quality of the digital signal. SQNR in PCM, there are several factors that affect the SQNR in PCM system, including number of quantization level, signal bandwidth, sampling rate, nature of carrier wave. Here are the explanation. You should note that. And mathematically, we can represent it as S by N, which is signal power divided by noise power. We can also say that P divided by delta square divided by 12. After that, we are moving forward to the application of PCM. Some of its most important and most common applications are space communication, satellite transmission, telephone, compact disc, etc. Thus, we can conclude that PCM system converts the analog signal to digital signal, removes the noise, and convert it back to the analog signal as the output. So, analog signal first of all convert to digital signal, and it removes the noise, and it converts it back to the analog signal as the output. Here is all of my discussion, and thank you so much for watching my video. Thank you.